In the name of Almighty God, the most compassionate and the most merciful, by the way, I welcome you all to your own channel. Today we are talking about part 2 of electron affinity. I am sure that you followed the first lecture. If you haven't watched the first lecture, then please, you have to watch the first lecture of the electron affinity and then switch on to this lecture. By the way, today we are talking about factors of electron affinity. I mean, which factors electron affinity depends on. First, come to an example. You will get and you will catch soon. For example, we have a nucleus. It has 2 protons. Now, what's electron affinity? You are closing one electron to the atom. The atom accepts that electron and instead it releases some electrons, some energy. Yes. Second, we have another nucleus. It has got more protons. Now you are getting close an electron to this atom. What do you say? What do you say? That the first atom catches the electron soon or the second? I think the second. It means electron affinity is directly proportional to Z or Z, or to the atomic number, or to the number of the protons. Yes. Number two, we have an atom which has got, for example, a proton and with this size. Now an electron is getting close to this atom, and we have another atom which its size is much larger to the first one. Now what do you think? Which atom will soon catch the electron or accept the electron? I think the first one. Why? Because this electron is near to its nucleus. So we can say electron affinity is indirectly proportional to the size. Directly proportional to the Z or number of protons or atomic number, and indirectly proportional to the size or volume of the atom. And number 3, we have electron configuration. If you are talking about electron configuration, if we have a stable electron configuration, I mean half-fill or full-fill. These are stable electron configuration. In this case, atom does not need electron. I mean, does not need to accept electron. Hence, we can say that electron affinity approaches to 0 or very less. What is half-fill? For p orbital, if we have 3, for d orbital, if we have 5, and for f orbital, if we have 7. This is half-fill. Also, for full-fill, we have p 6, d 10, and f 14. This is full-fill. Now, in half-fill and full-fill, electron does not need to accept electron. So, we can see that electron affinity approaches to 0 or it is very less. In other cases, if we have P4 or P2 or D4, D6, and for F also, On that occasion, atom needs to accept the electron and put it in one of its orbital. These are the factors which the electron affinity depends on. Now, write it down. We will come, inshallah, in the variation of the electron affinity with the periodic table. Should I erase the board? Yes, of course. I request from all of you, please share my channel with your friends, because I need it very, very much. By the way, variation of electron affinity in periodic table. Whenever you're talking about variations of every aspect of the chemistry or physics in periodic table, we mean first in period, second in group. Whenever we are talking about period, I mean from left to right, left to right. Now, whenever you're talking from left to right, what do you think? Xi or Z is increasing. If Z is increasing, electron affinity, it depends directly in proportion to the Z. So it also, or it should be increased. I mean, for example, in second period, we have lithium, beryllium, boron, we have carbon, nitrogen, oxygen, fluorine, and neon. Now, what do you think? What is the atomic number for lithium? It's 3. This one is 4, 5, 6, 7, 8, 9, 10. Now, Z is increasing. If Z is increasing, electron affinity must increase. So it should be lithium. This one has the most electron affinity, and this one has the least electron affinity in second period. Like this one, it should be lithium, beryllium, boron, carbon, then nitrogen, then oxygen, then fluorine, and then neon. This is expected, but it's not right. It is wrong. Why? Because electron affinity does not depend only on Z or atomic number. It depends also on electron configuration. If we are talking about electron configuration, so this is 2s1 in the last shell, 2s2, 2p1, 2p2, 2p3, 2p4, 2p5, 2p6. This one has fulfilled. If it is fulfilled, so it does not need electron anymore. It has already 6 electrons in the last p orbital. In here it is half filled. In here it's also full filled. So neon comes to the least one. Then we have nitrogen. Then we have beryllium. Then we have lithium. Then we have boron. Then we have carbon. Then we have oxygen. Then we have fluorine. Neon, nitrogen, beryllium, and then lithium, boron, carbon, oxygen, and fluorine. There is also another change in here with the lithium and boron. Why? Because lithium is 2s1, and this is 2p1. Now, what do you think? If another electron is added in lithium, so its orbital will get full, so it will be more happy. So we have a smaller change between lithium and boron. So I can say neon, then nitrogen, then beryllium, then boron, then lithium, then carbon, then oxygen, and then fluorine. This is the correct one. We have neon, nitrogen, beryllium, a smaller change between lithium and what? And boron, and then carbon, oxygen, and fluorine. This is the variation of the electron affinity in period. Now come to the group. If we are talking about the group, whenever you are talking about the group, so we mean from up to down. From up to down, what do you think? From up to down, number of shells is added. If numbers of shell is added, it means the size is increasing. If size is increasing, electron affinity must be decreased. If we are talking about the first group, we have what? Lithium, sodium, potassium, rubidium, cesium, like this one, francium. Now what do you think? It has got two shells, 3 shells, 4. So it means from the nucleus. So size is increasing. If size is increasing, electron affinity is decreasing. Cesium is less, then rubidium, then what? Potassium, then sodium, and then lithium. Cesium, rubidium, potassium, sodium, and what? And lithium. We have some exceptions in group 14, 15, 16, and 17. Write it. We will come inshallah on the exceptions. Okay. Should I erase the board? Yes, sir. I love you very, very much, all of you. Come to group 17. What are the elements which we have in group 17? Name, please. What are the elements in group 17? Exception. In group 17, we have fluorine, chlorine, am I right? Bromine and iodine. What do you think? What do you expect that size up to down, size is increasing. So electron affinity must decrease. It means fluorine has more electron affinity than chlorine, than bromine, and than iodine. Size is increasing. This size is increased. So electron affinity should decrease. So it has the least electron affinity in this group. Now, this is expected, but it is not right. It's wrong. Why? What is electron affinity? Accepting an electron. Accepting an electron. So, if we talk about fluorine, this is fluorine nucleus, and it has 2 shells. Now, if we talk about chlorine, chlorine is in third period. It has 3 shells. How many electrons does fluorine have in its last shell it has 7 electrons. 3, 4, 5, 6, 7. How many electrons does chlorine have in its last shell? 7. 2, 3, 4, 5, 6, 7. Now what is electron affinity? An electron is coming and the atom accepted. What is electron affinity for this one? The same one. Electron is coming and this atom is accepting that electron. If fluorine accept the electron in the last shell, what do you think? It has already 7, and the quantum number for this one is 2, and the quantum number for this one is 3. It means the number quantum of the chlorine is much bigger than fluorine. What does it mean? It means it has already 7 electrons and it has more repulsion than the last shell of the chlorine. Why? Because size is very small. Now if you put this electron, the repulsion will be much more. For this result, fluorine does not need to accept this electron. Why? Because it has got already a problem in its last electron. For this result, fluorine does not need to accept the electron, but chlorine needs. Why? Because it does not have much more repulsion in its last shell. So we can say that we have a smaller change with this one. So the correct is chlorine, fluorine, then bromine, and then iodine. Fluorine has got more electronegativity, but electronegativity is another topic. It is different from the electron affinity. In electron affinity, the atom should accept the electron. If atom should accept the electron, so it should have a place in order to put that electron. Now in here we have much more repulsion, so atom does not have any place for this electron. For this result, the electron affinity of this one is smaller than the electron affinity of the chlorine. I think you have got. Now write it. We will come inshallah on the group 14, 15, 16 and 17. Okay. I have written the elements of group 14, 15, 16 and 17. The same which we had in group 17. It means a change between the chlorine and fluorine. The same is happening in all of these one. Sulfur with oxygen, phosphorus with nitrogen, and selenium with carbon. So we have Si is more, then carbon, germanium, and Sn. In here, nitrogen has more or phosphorus? No, phosphorus. So we can say phosphorus, nitrogen, then arsenic and Sp. In here, sulfur, oxygen, Se and Te. But there is a smaller change. Oxygen has got the least one because of its property. So we can say sulfur, then Se, then Te, then oxygen. Here, chlorine, fluorine, then what? Bromine and iodine. One thing more. Every element of the 17th group has got more electron affinity than 16. Note. Every element of group 17 has more electron affinity compared to group 16. If you want to compare sulfur, it is less than fluorine, chlorine, bromine, iodine with everyone. I mean it is less than fluorine, it's less than chlorine, it is less than bromine, and it is less than iodine. In some books we have questions that they put the question like this one, for example, oxygen, sulfur, and they want to compare with fluorine, chlorine. Which one is less, or which has got more electron affinity? I mean, I'll write an example. Have you finished this one? Finished or not? Yes. For example, arrange in order of electron affinity. For example, we have sulfur, oxygen, chlorine, bromine. Now, which has got more electron affinity and which has got less electron affinity? What do you think? First, these two belongs to group 16 and this one belongs to group 17. In group 16, oxygen has less electron affinity, sulfur has more. So it is like this one. Also, in this group, chlorine has got more electron affinity than bromine. Note, in all periodic table, chlorine has the highest electron affinity. When we talked about ionization energy, helium has got the highest, and in here chlorine has got the highest electron affinity. So we can say chlorine is more than bromine, than every element, and in group 16 oxygen has got the least one. Now, when you compare these two groups, 17 has more than 16. So we can say chlorine, then what? Bromine, then sulfur, and then oxygen. This is the correct order. Have you got? Yes. Finish, please. We have another example. Should I erase the board? Number 2. Number 2. Which is more stable? Lithium minus or boron minus? Which is more stable? What do you think? First, we know lithium has 3 atomic number, so electron configuration will be 1s2 and 2s1. If we talk about boron, the number atomic for boron, we have 5. So it is 1s2, 2s2, 2p1, 2, 2, 4, 4, 1, 5. But when we talk about lithium minus, it means we have another electron. It has accepted 1 electron more. So we can say 1s2, 2s2. And when we talk about boron minus, it means it accepted 1 more. So it will be put it in P. Why? Because it has empty place. So 1s2, 2s2, 2p2. Now what do you think? This is fulfilled. If this one is fulfilled, so it would be more stable than this one, because it's not half filled and neither it is full filled. So we can say that lithium is more stable than boron. Lithium minus, we are not talking about lithium. Lithium minus is more stable than what? Boron minus. Sometimes this question change its shape, and they can ask which one will lose electron easily. For example, lithium minus 1 and boron minus 1. Which one will lose electron easily? What's the electron configuration for this one? It is 1s2, 2s2. What's electron configuration for this one? 1s2, 2s2, 2p2. Now this is fulfill since it's stable, and this one is not stable. If this one is not stable, so it will lose electron very easily. So we can say that boron minus will lose electron easily compared to lithium minus. Finished? By the way, it was our last lecture on electron affinity. Inshallah, for the next lecture, we will talk about electronegativity. Inshallah. By the way, Allah Hafiz.